6, so a reflecting pool that is 200 feet long by 30 feet wide is to be surrounded by an X foot wide and 2-inch thick concrete sidewalk. Okay, so we have a really long, like, reflecting pool. So it's 200 feet long, 30 feet wide. And we're going to have this, like, sidewalk going all the way around it. Have you guys seen, like, the reflecting pool in DC? Imagine that. Okay, and this sidewalk is going to be X units wide. Okay, and we want to know how much this concrete is going to cost us. So it says the company wants to spend at most $2,000 on the concrete. So how wide can the sidewalk be? Okay, the concrete creates some kind of volume. It has a height, it has a width, it has a length, right? So do you guys notice how the units for the concrete, when it says the concrete costs $5 per cubic foot, that's kind of giving you a clue that you should be talking about the volume. Okay, so we got a lot of stuff we got to do. Basically, we got to figure out the area going all the way around, like of just this part here. We want to know the area, so we're going to find the area of the big rectangle. We're going to subtract out the area of the smaller rectangle. Does this make sense? All right, and then we're going to multiply by the height. Okay, what do we want our units for our volume to be in? What do you guys think? Units, cubic feet, right? We want cubic feet. So when I talk about 2 inches, do you think I want that? No. So let's make 2 inches the same as 1/6 of a foot, right? We'll use fractions. So our volume is going to involve some kind of area. Maybe I'll talk about the area first. Our area is going to be this and this. So we had 30 originally from here to here. And how much did I add to the top and bottom? X and X, right? So I've added 2X. So I'm going to write it as 30 plus 2X. And the same for the 200, it's going to be 200 plus 2X. So we have the 200 plus 2X multiplied by the 30 plus 2X. And then we're going to subtract out what? The area of that pool, which is 30 times 200, right? Okay, so that's going to be 6,000. And you can FOIL it out or you could leave it. It doesn't matter. So there's like pros and cons to both. If you don't FOIL it out, you got to put all that into your calculator. So it's a lot of typing, a lot of room for error if you like mess up and forget a negative or something. So if we FOIL it out, we do get 6,000. Our outer is 400x. Our inner is 60x. See, I almost messed it up. Plus 4x squared. And then we have minus 6,000. So those, sorry, I wrote 600 and I said 6,000. So 6,000 and 6,000 cancel. So those two 6,000s go away. Okay, you see it? So that's our area. So to get the volume, what am I going to do? So that was my length times my width. Yeah, times the 1/6, perfect. So I'm going to take all of that, and I'm going to do my area times my 1/6. So basically, I'm going to have a volume equation of 4x squared plus 60x, plus 400x, right? So let's write 460x, all divided by 6. And I could reduce that, divide by 2 on top and bottom. I'm not going to. I'm just going to leave it like that. So you with me so far? We want this to be at most 2,000. So set your volume equal to, oh wait, not 2,000. That's not the volume. That's the price that we're spending, right? Okay, we got more. So that's our volume. Those units are in cubic feet. What do I do to get the cost? Yeah, it's going to be times that 5 cubic feet, right? Or $5 per cubic foot. So we're going to take that. So our 4x squared plus 460x over 6, and we're going to multiply by 5. And we want our cost to be at most $2,000. Okay, so I think we're good. Do we agree?
Yeah.
Sweating. That was a hard one. All right, so let's go to our graphing calculator. And we can do this two different ways. So remember, we talked about this last time. You can set one of them in for y1, so like 2,000 in for y1. And then for y2, you can put this 4x squared plus 460x times 5 over 6. You can put that in for the y2, and you can find their intersection point. Okay, what's the second way that we did it? Do you guys remember? You could just subtract that 2,000 over, right? And then subtract it out. So it's up to you, and then put it in for y1. So let's do the one where I guess you guys are already typing, so up to you, whatever you want to do. Maybe we'll just do the y1 and y2 since you're already typing it in. So let's do 2,000 for y1. And I'm going to do 4x squared plus 460x divided, or times 5, and then all divided by 6. So you can just do times 5/6. So when we hit graph, we're not going to see anything. So what's wrong with my window? Why do I need to change this? What does it need to go to? Think about my variables. What is x? X is the width of the sidewalk, right? Wasn't that what x was? Is x going to be like 100 feet? Probably not. It's a really wide sidewalk. So I'm going to keep my x. I think it's okay that it goes up to 10, but maybe I'll do 0 to 10. I think that's fine. If you want to be on the safe side, you could do 0 to 20. Totally fine. But what was y that I'm graphing? Yeah, it was 2,000 for one of them. So I want to go up even higher so I can see it. So we could go up to like 2,500, 3,000, whatever you want to do. So now when I hit graph, I'm going to see my 2,000 line graph first. And then my other one, which is an x squared equation, so parabola, goes second. So what am I trying to find? Where it intersects, right? So I do second, trace, intersect. So that's the easy one because you just go right on it and hit enter, enter, and enter. So it was x equals 5. Probably not hard to solve by hand. We could probably get it all on one side and factor or use quadratic formula. But we're trying to learn our calculator, right? So we can do it this way as well. So x is equal to 5. Is that what it wanted? So go back to your question. It says, how wide can the sidewalk be? So it can be 5 feet wide, right? Done. Are we feeling better with our calculators? Okay. All right, so the next one. So the product of 3 consecutive even integers. So consecutive even integers, we did this last year. So if x is my first one, my first even integer, I had to skip over the next number to get to the next even integer. So what do I write? X plus 2. And then the last one is x plus 4. Okay, so the product of these 3 consecutive even integers, so I'm going to multiply all 3 together, is equal to 168 more than 180 times the middle number. All right, are you all interpreting with that like that in your head? You guys see where we're getting all this? So we're using all of our keywords. So 168 more than, so plus 180 times the middle number. So our middle number is x. Okay, so it says write an equation and to find the numbers and use a graphing calculator to find the solution. Okay, so this one's a little bit tricky, like when you do the y1 and y2. Let's do it where we set it equal to 0. So I'm going to do 168 plus 180 times x plus 2. And I'm going to subtract out x times x plus 2 times x plus 4. So you could put a big parenthesis around all of that. Your calculator actually won't. You don't need it. It will do order of operations. It will multiply everything before it subtracts. Oops, sorry. There you go, you got it. So on our y equal, we're just going to do y1, not y1 and y2. And we're going to put in a lot of stuff. So 168 minus, or no, plus, sorry. 180 times x plus 2. Don't you feel super nerdy when you're like typing all this stuff in your calculator? All right, and we can hit graph. Mine is still set on that last window, and it looks like it's crossing the axis somewhere. Now to find a 0, I need to go above and below the axis. So we're going to have to adjust this window slightly. So how should I adjust it so I can see below the axis as well? So under window, maybe make y min like negative 100 or something. It didn't move very much because I was at 2500. It's barely. Let's do window as negative 1000, just so we can definitely see both sides of that. Do you guys know what I'm saying? Like when you do a 0, you need on the left and the right side, left bound, right bound. So we're going to get on the left bound, which is going to be above the axis, and the right bound, which will be below in this case. So I'm going to do second trace 0. So I'm going to get on the left of the 0, so I'm going to be above the axis. And then I'm going to get on the right of the 0, so below the axis. Then go to where you think it is. So I got 12, 0. So x is 12, the next one is 14, and the last one is 16. All right, so let's stop there.